Hello everyone, this is a bit of an improvised pitch for SSSOM, the simple standard for sharing ontological mappings. We sometimes discuss this in the context of sharing fair semantic entity mappings, so this is what I will do today as well. My name is Nicholas Martinsoglu, but obviously there are many people involved in the development of the standards. So this is the kind of general pitch. If like in the course of data generation in a global setting, so for example here we have a fabricated example where various data providers like this one up here and this one up here and these two here generate anatomical data for their research, for example, and they decided to eventually, when the time came, to standardize their data using terminologies or ontologies. And what happened was that because these were kind of like disconnected communities maybe, that these two institutions here on the side, they decided to employ the Uberon standard, the Uberon ontology for anatomy. This institution down here, for example, the foundational model of anatomy ontology, and this institution up here maybe created their own new ontology because either they didn't know about these two or any other, or they had some specific needs and therefore decided that it would be better to just create their own. And so when we say semantic space, we don't really just mean a space where that is defined by some kind of ontologies, but kind of any space, any data space in which information about that is linked to some domain of interest is created, like a database or other kind of controlled vocabularies as well. So the big problem is that this kind of act of standardizing data is extremely cost intensive, and it's so high that it is unlikely that once you got these institutions to standardize their data, that you can one morning go to them again and say, look guys, the Uberon ontology is much better than your custom ontology or FMA. Please, everyone adopt Uberon so that we are fully interoperable and everything just fits together. So because the initial cost was so high, it's most likely that these organizations would say, okay, I have now standardized my data. I'm not going through the standardization process again. So this kind of establishes the need for bridging between these semantic spaces using some kind of mappings. And when we say mappings, what exactly do we mean? So we are talking in particularly about entity mappings in this context here. So an entity is some kind of symbols, such as a code in a terminology, a class in an ontology, an enumeration in a data model, or simply a string in a text field in some data spreadsheet that is intended to refer to some real-world thing. So for example, here on the left side, we have a string Friedreich's ataxia that is mentioned in some spreadsheet about diseases, which is intended to refer to the disease of Friedreich's ataxia. And then we have this OMAP code 441554 in some Excel spreadsheet, also intended to refer to Friedreich's ataxia, the disease. And when we say an entity mapping, we really mean a correspondence, a link between this symbol and on the left and that symbol on the right. Now, so mappings are absolutely pivotal for many domains, and not just the biomedical domain, but literally any domain in which global data integration efforts have to be performed. But yet it is really, really hard to find good mappings publicly available and ready for reuse. So why is that? So first of all, establishing a proper mapping life cycle where mappings are created and maintained over time requires expensive expertise. So you need people that understand about semantics, you need people that understand about data engineering, and you need people that understand the domain so that they can review and potentially augment the mappings that are being created. Then we need to remember that the mapping space is n squared. It's a huge space. So n is the number of semantic spaces that exist out there. And if you look at the domain, like for example, the clinical domain, where you have like maybe you could have 20 different standards for representing disease concepts, from SNOMED, ICD to DO, Mondo, and OMIM and Ordo and many others, then of course the mapping, you have to potentially map between and across all of these. So the space is insanely big and it's expensive to get it all done. Then, of course, mappings are subject to constant change because the sources are changing. Every time a new source is released, it may be that previously good match can be replaced by a now better match. And very often, mappings are created for some kind of different purpose. Yeah, so rather than saying a mapping is good or a mapping is bad, most of the time mappings are fit or unfit for a particular purpose. But implementing this fitness for purpose or making this explicit is really hard to test and implement. So it's our hope that we can do better with a proper standard for sharing these entity mappings. We want to by sharing them. So if we share mappings around, we avoid creating the same mapping over and over again. We want to enrich mappings with metadata to increase the cross-purpose reusability. So when they're created for different purposes, as we said before, and make it also possible to combine those mappings from different sources together, and also build a coordinated and decentralized efforts of human curators that can benefit each other, similar what we've already established for ontologies, such as in the biomedical domain with Obo Foundry. And so the general tenet is our society should not have to fund this incredible duplication of effort we currently have of connecting various semantic spaces together. Once should be enough. So what are the three kind of main things that we try to achieve with SSSOM? So the first is we want to promote documenting specifically the semantic mapping predicates to enable cross-purpose reuse and also inference over mapping predicates. So most of the mappings out there in practice are basically some kind of two-column tables with like one identifier in the first column and another identifier in the second column. And what we try to promote here is the use of standard vocabulary, in this case SCOS, with some extensions for documenting the predicates between those mappings. And so what this gives us, for example, that you can see here is that if you have a code that is an exact match to another code, and this code is a broad match to yet another code, we can infer certain things about those mappings. So for example, from this orphanet to the Mondo code, we can say if orphanet is exact to Mondo, then obviously Mondo is exact to orphanet. So we have the possibility of inferring a symmetric walkback. Or if Mondo is a broad match to this ICD-10 code, then we know that this ICD-10 code is a narrow match to this Mondo code, so an inverse walkback. Or we can do mapping chains. So we can say if orphanet is an exact match to Mondo and Mondo is a broad match to ICD-10, then we can infer that this orphanet code should be a broad match to this ICD-10 code. And this gives us a little bit of a way to reduce cost for managing large numbers of mappings in this n-squared space we talked about before. The next big thing is the documentation of mapping justification to facilitate trust across use cases. So rather than just saying A is an exact match to B, we also provide and encourage to provide mapping justification that say, for example, this match was established or it's justified by a lexical matching process, and then there are various degrees in which you can refine this justification. For example, in this case, you say so the match was done on one specific attribute of the object with one specific attribute of the subject, using this and that string after performing this and that pre-processing. So that's kind of like one very detailed justification. And another example, of course, is manual mapping curation, where you can say something like, okay, this has been performed by this author, and this author had a confidence of 70% that this match was positive. So there are lots of different kinds of justification, and they're all encoded in a special vocabulary about that. And then lastly, so this is the anatomy of how a semantic entity mapping look like. So you have basically the simple subject predicate object triplet. The subject can be, you can capture further convenience metadata about the subject and the objects, such as, for example, the label or a category, obviously the ID. The same for the predicate as well. And then you have these justifications hanging off this this mapping as well, where you can document various different aspects about the provenance of this mapping. Okay, lastly, this is how a SSSOM table looks like. It's basically a glorified TSV file. So you see down here, this is kind of like the mapping part where you see the columns, object ID, predicate ID, subject ID, and many others that represent these fields that we just talked about. In particular, the predicate ID, where you have to say explicitly what's the kind of semantic precision of your match. And then you have embedded in those SSSOM files also at the top a hash commented like mapping set metadata aspect. So you can say things like, okay, this mapping set was created by these guys in this organization, it has this license, and this is how you should interpret the identifiers that are used in this mapping. All right, so this is basically it. I hope that you kind of got a bit of a sense of how SSSOM works and what it is. If you have any further question, feel free to just Google SSSOM. We've written various papers about it, or go here to this address to get some additional information about the standard. Thank you very much.